kind of just swing it back and forth this way real quick, and we're going to talk about it. As it's swinging back and forth, imagine that there's a pin attached to the bottom of that. And imagine that it's staying real steady, just going back and forth. Okay? And that pin has an ability to kind of absorb the motion with the floor so that it's in contact with the floor the whole time it's going back and forth. It's always touching the floor and riding. What type of shape would it make on the floor?
Straight line.
Straight line. Okay, good. All right. I want you to just kind of keep that in mind. We're going to start talking about springs real quick. Springs are another good example of simple harmonic motion. Okay? Repetitive motion, vibration. Okay? Put a mass on. Now, for the period of a spring, in a complete cycle of a spring, it's all the way down and all the way back to where you started. Okay? All right, so let's see if we can figure out the period of the spring. We're going to let it bounce 10 times, and we're going to time it and calculate the period. Got it? You ready? Okay. So on the count of 3, get your iPhones ready, or your Droids, or whatever you're using. Okay? 1, 2, 3, go. Stop. What'd you get?
Does the fact that it's kind of going like back and like diagonally, like it's not moving up and down perfectly, does that change anything at all?
It makes it rev a little bit more, so that absorbs a little bit of energy, but doesn't affect it too much. Okay, but let's go ahead and do it one more time, just to make sure we got good values. Okay, you ready? 1, 2, 3, go. Stop. What'd you get? About 6.2. So about the same. 6.4, 6.2, whatever. Okay. So we had 10 oscillations, and the time was 6.2, 6.3, something like that. So what's it going to be for one oscillation?
0.63 seconds.
So for the period of that spring, at that time was 0.63 seconds, right? What do you think makes a difference on the period of the spring?
Wait.
Okay, the mass?
Yes, mass.
Okay, let's see. Okay, I was going to say, you want me to go bigger or smaller? I already know the answer. How do you like? Bigger? All right, so here we go. You ready? 1, 2, 3, go. Stop. What'd you get?
9.87.
Did it make a difference?
Yeah.
So the mass with the spring made a difference. Okay? All right. What else might make a difference?
The number of coils in the spring.
The size of the
Gravity.
Number of coils, the size, whatever. Turns out it kind of depends. And you say size, it kind of depends upon what you mean by size in a sense. But like the stiffness of the spring, which is kind of determined by the diameter of the coil, right? Not how big around it is this way necessarily, but the steel that makes it up. If it's really, really stiff, and depending on the material, this is the same mass I started with a minute ago, where we had 0.63, okay? If it's really, really stiff, it's going to be one value, and if it's not, maybe another. Okay, you ready? Let's time it and see what we get. 1, 2, 3, go.
Oh.
2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, what did you end up with?
12.2.
I want one of those.
12 even.
So like twice as long, it seemed like, right? The period was like twice as long. Okay? All right. Now, here's the thing. We know that for the pendulum, the length and gravity makes a difference.